All right, so we should all be on this page. It should say conditional probability on it. That's what we're going to talk about today, which is a little different than the theoretical that we talked about last week. So with the theoretical that we did on Thursday, Friday last week, that was when we were saying, what are the chances of me drawing a specific card from a deck and rolling a dice? Or we talked about them being independent, dependent, like if I pull a marble out and I put it back in or I don't put it back in, how does that affect like my overall chances of something happening? Conditional probability is a little bit different than theoretical. So we're still going to have multiple events, like two things happening in the same situation. So it says here, given events A and B, conditional probability is the probability of event B occurring, so like the second thing happening, knowing that event A has already happened or already occurred would be another way that they might say that. So conditional means, what are the chances of the second thing happening if I know what happened on my first situation that I was presented with? So you'll kind of see that the wording is going to be a little bit different in these problems. It's going to say, like, find the probability of this given that this happened. That's what makes this conditional versus like theoretical like we saw last week. The notation is also going to be a little bit different. You're going to still see that capital P for probability, but then next to it, like in parentheses, you're going to have a capital B representing event B, and then there's going to be this line that kind of goes straight up and down, and then that's where A is going to go, and that's going to be right after it. So this is saying, like, what's the chances of B happening given that A has already happened? So that line that we see, if I were to read that, it would probably say given. So like down here where it says read as the probability of B given A. There is a formula for this, and we're just going to talk about it briefly. We're not going to use this formula a ton today because you guys are going to see something that happens a lot with this formula, and so eventually I'll show you a little bit of a faster, shorter way to handle this. But the conditional probability formula looks like this. That probability of B given A is, we're going to have a fraction, and on the top, it's going to be the probability of A and B together. And those are going to be written out separately. So it's going to be the probability of event A happening times the probability of event B happening, all over just the probability of A happening. So you'll notice in all the fractions that the probability of A, so that's like the first thing, happening is going to show up 2 times. And the reason that that happens is because that's what's always given. We know that that has to be occurring in order for us to do the problem. Because it shows up 2 times, you're going to be able to cross it off on your problems. And so really you only need to think about the probability of the B happening. But we're going to kind of go through the process so you can see what I mean. So down here where it says examples, number 1 says Mitchell drew a card from a standard deck of playing cards. If you still have that cheat sheet from last week, you might want to have that out because we're still going to be talking about deck of cards and dice and months and all that stuff. So if you don't know those things, you might still want to have this piece of paper out. So this one's saying he draws a card from a standard deck. What is the probability that he drew a queen given that the card was red? So when I read the problem, that first probability it mentions, which is saying that he drew a queen, that's like event B. Because whatever follows the word given is going to be event A. That's what had to happen first before the second thing could happen. So I'm going to set up my fraction here. And on the top and on the bottom needs to be the probability of A occurring. And A is always what follows the given. So it says given that the card was red. Well, how many cards in a deck are red? 26, because there's 52 total. Half are black, half are red. So 26 over 52 is going to go on the top. And it's going to go on the bottom. Now on the top, we also need to include the probability of B happening. B is when they said he drew a queen. How many queens are in a deck? 4, okay, because there's one in each suit. So 4 out of 52. So if I look here, and again, you're going to notice this, the top and the bottom should have fractions that look the same. And because they do, we can reduce it. So we can get rid of the 26 over 52. So really, we're left with the 4 over 52. But can we reduce that? To what? Good. 1 over 13. Okay, number 2. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? So again, if we think about our fraction, the given that is an odd number, that's the first event. That's event A. So if you have numbers 1 through 100, how many of those numbers are going to be odd? 50. Half or even, half or odd. So 50 over 100 is going to be on the top for event A and on the bottom for event A. Now, event B is when it says that it's a perfect square. So remember, perfect squares would be, like, think of it if you could square root the number and you get a whole number as your answer, that's considered a perfect square. So like I can't square root 7 because there's no whole number times itself that is 7. But 9 is a perfect square because 3 times 3 is 9. So think about those numbers, like what's 1 squared, what's 2 squared, 3 squared, 4 squared, 5 squared. Those numbers that you're getting are going to be your perfect square. So like 1, 4, 9, 16, 25. How many total are there? And if you don't know off the top of your head, that's why you have this sheet. And on the back side is all the numbers. So go through and tell me how many perfect squares there are from 1 to 100. Anyone know how many there are? So it'd be 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. There should be 10 total. So you're going to put 10 over 100 there. Just like before, though, we can cross off the 50s over 100 because there's one on the top, one on the bottom. So we're left with 10 over 100, which would reduce to what? Good, 1 over 10. So eventually we won't need to set it up like specifically like that because we'll start doing problems that are maybe laid out a little bit differently. And we won't have to set those up. But that is really the process that's happening here when you're trying to figure out this conditional probability. Now, 3 and 4, right underneath this, they switch gears a little bit on us. Okay? They start talking about people that are maybe in 2 different categories and they're either in one or the other, or maybe they are doing both things. So think about like you guys as students, you're taking classes throughout the day. I could start asking you guys questions like how many of you are in Algebra 3? Everyone in here would raise their hand. And then I could say how many of you are taking like creative writing, and maybe some of you would, and maybe some of you wouldn't raise your hands. Or how many of you are in a sport versus not in a sport. Or you do this or you do that outside of school. You have a job or you don't have a job. So like we could start asking those different kind of questions, and instead of being able to just pick and choose like from a deck of cards or something like that, we have to start thinking about how would I maybe arrange the numbers that I'm working with here. And we're going to use something called Venn diagrams. You guys know what a Venn diagram looks like? It's like when you have those 2 circles and they kind of overlap in the middle a little bit. So these problems are going to have Venn diagrams in them. So you're going to have 2 circles and they're going to kind of overlap in the middle there. So let's read through this here and figure out what numbers need to go on our Venn diagram. It says there are 62 people that take yoga class, and there's 48 people who take spinning class at the gym. So we're comparing people who take yoga to spin. 15 people that take yoga also take spin. So there's 15 people who take both classes. Anytime that we have a number that talks about being in both, that's the number that goes in the middle where those circles overlap. So we're going to put 15 in the middle because those are people that take both classes. Then it goes on to ask a question here. Let's save that for a second here. So I'm going to stop right here. I'm not reading this yet. Let's come back here and fill in the other halves of our circles. So it said that there's 62 people who take yoga, but there's already 15 people who take both. So I don't want you to put 62 in here because then you're double counting people. We have to take 62 and subtract away the 15 that we know take both classes. So what is 62 minus 15? 47. So there's 47 people who only take yoga and nothing else. The same thing's going to happen with the spin class. We have 48 people who take spin. But again, 48 take away the 15 would be what? 33. All right, so there's our Venn diagram. So now let's read what the problem says. If a person from these groups is selected at random, find the probability. So find the probability that he or she is taking yoga if you know that they take spin. So I'm trying to underline those a little bit differently so you can see where the given probability is versus like where's event A versus where's event B. Okay, we're trying to distinguish that. Remember what I said, everything that comes like second in the problem is going to be your event A. That's what we want to have happen first. So I want to know how many people are taking spin. How many total people in the problem are taking spin? Because that's going to go on the bottom of my fraction. 48, because it says 48 people take spin. That's including the 33 who are only in spin and the 15 who are in both. Okay, and then it says, find the probability that he or she takes a yoga class. So you know that they have to take spin, so we're only going to look at the spin circle. So I'm just going to kind of go around that in blue. But I only want the top number to be the people that are also possibly in yoga. So are the 33 people also in yoga? No, those are only in spin. So what number should go on the top? 15. So 15 over the 48. 15 people who are taking yoga, given that they already take spin. Can this be reduced? To what? 1/3? Is that what you said? Okay. If you're unsure, type the fraction to your calculator and your calculator will reduce it for you. You just have to type in the fraction and hit enter. All right, let's take a look at number 4. I want you guys to help me set up my Venn diagram here. So I'm going to draw 2 circles, overlap a little bit in the middle there. All right, let's read through it here. It says, of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. Let's just stop here and let's digest this information. All right, 3 of the athletes are also in band. Where should that number go? In the middle. There's 3 who do both. Okay, so one side of my circle is going to be for my athletes. The other side of my Venn diagram is going to be for people in band. What's the number I should put in for the athletes portion? 10. Why 10? Yeah, take away the 3 that's shared. So there's 13 athletes, take away the 3, you're down to 10. How about for the band then? 6, because there's 9 in band, but again, take away the 3, so we're down to 6. Okay, real quick before we move on here, I just want you guys to notice something. 13 are athletes, 9 are in band. 13 plus 9 is 22. How many kids are in the class? 30. So how many kids are we missing here? 8. There's 8 kids that are unaccounted for. That means that those 8 kids are in neither of these things. Like they're not an athlete and they don't do band. So they didn't have that in the last problem. We were talking about like the yoga and spin. Everyone was accounted for in the yoga and spin problem. This one has 8 kids that they're not including right now. So we want to just make sure that we're aware of that because we're probably going to need to know that when we set up our fraction. All right, so now let's read on. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. All right, so Let's start with the not an athlete, because that's going to be the number that goes on the bottom. Using your Venn diagram, how many do we have that are not athletes? 6. Okay, but how many were we missing up above? 8 students. And those are in neither. So those would also be considered not athletes. So we need to take the 6 that we already know we have here, and we need to add to the 8 that we were missing from our total students. So what's 6 plus 8? So that actually goes on the bottom. That one's a little bit different than the last problem because we have to think about those kids that they didn't include. Okay, now it says on top here that this student is in band. How many are in band? Just band? 6. So 6 over 14. Yeah, Nevaeh.
What do you mean 6 from?
So see how it says in the problem up on the top, it says 9 are in band. And then it follows that and it says 3 of them are in band. So that's the overlapping. We have to just subtract 9 minus 3. Can this reduce, guys? 6 over 14?
Yeah.
To what?
3/7.
Good, 3 over 7. All right, do we have any questions so far on Venn diagrams or setting them up like with those fractions? All right, so we're going to switch gears a little bit here. At the bottom of this page, there's something called a two-way table. And this is just a different way that they're going to maybe give you this information that we've seen on these problems. So they're still going to be talking about people that maybe they surveyed and they asked questions about. But instead of us doing like a Venn diagram or trying to set up our fraction, we're going to use two-way tables. Personally, I feel like two-way tables are a little bit easier for us to navigate through. It's a little bit tricky at first because you have to understand how to read the problem and how to go about setting up your fraction. But once you guys see how we do it, I think you're going to catch on pretty quick. Okay? So a table that records data that talks about two different categories or more than two different categories is going to be displayed in a two-way table. So you can see down here, they surveyed 50 people, 50 students, and those students were asked whether they like to prefer to watch hockey or they like to watch football. And then they kind of broke it down. So we have it broken down into the boys that were asked, the girls that were asked, and then what their answers were. The first thing that I would suggest when you guys have a two-way table is to find your totals. So when I talk about totals, I'm talking about totals of the columns and totals of your rows. So like adding those numbers together. So let's start with this column of the boys. There were 18 who said they prefer football and 10 who said they prefer hockey. So there's 28 total in that column. How many total girls are there here? 22. Okay, now I also want us to add totals for the rows. So 18 plus the 6, those are in the football category. That would be 24 together. And then 10 plus the 16 would be 26. All right, so now let's look at these problems that they're asking us to answer. And you'll notice that they have that notation, that little bar. Remember, that means given. So we want to find the probability of someone saying they preferred football given that this person we asked was a girl. So when you read the problem, you always want to start here. Like, what is coming after that symbol? What's the given that we have to focus on? For this one, it's the girl. So you want to look at the column that has girls and you want the total number. The total number of girls that we said we asked was 22. That's the number that's going to go on the bottom of your fraction. Then, using this column, so using the girls column that we're focused on right now, which number represents those that said they prefer football? 6 or 16? 6. So that's going to go on the top. Can you reduce that?
Yeah.
To what? 3 over 11. Okay, let me erase some of my markings here and let's start over for letter B. Letter B wants us to find the probability of it being a boy given that they said they prefer hockey. So hockey comes second. So that's going to be the number that goes on the bottom of our fraction. So we look at our chart. We look at the total people who said they prefer hockey. So that's going to be this row. How many total did we have there? 26. Now in that row, how many of those that answered were boys? 10. So you put 10 over 26. And how does that reduce? Good. 5 over 13. You guys follow where I set those up, like how I got those numbers, why I'm setting it up that way? Okay, so let's flip the page over. We're going to do some more with these two-way tables. Okay, next one here, new table. It says we have a survey of 150 total students who were asked if they take French or Spanish. They've got it broken up by grades and then what they answered. First thing first, let's total up our numbers here. So once you guys take a minute, I want you to find the total. So add up all the numbers in your columns and add up the numbers in your rows. Okay, I put the totals up there. Just make sure you guys got the same numbers I did. Now, if you look at part A, it doesn't have the given notation. It just says a seventh grader who takes French. So we're not having to follow what we did on those last ones. This is just saying how many seventh graders take French out of the total number of kids that were surveyed here. So seventh grader who takes French would be right here. There's 25 of those. And according to the problem, how many kids did they ask this question to? All of the students. It says the table shows the results of a poll of 150. So you're going to put 25 over 150. And then again, we would check to see if that reduces, and it does, down to 5 over 6. Okay, that one's different because it doesn't have that given bar that we were looking for on those other problems. Now, the rest of these do. So B wants us to find the probability of getting an 8th grader given that they take Spanish. So we're going to start with all the kids who said they take Spanish. How many kids total take Spanish? 68. So that goes on the bottom. And in this column here, because that's where we got our 68 from, how many are in 8th grade? Oh, shoot. Okay. How many are in 8th grade? 33. And I don't think that can reduce. Unless I'm wrong. If I am, tell me. Can it reduce? No? Okay. So next one. What number are you going to put on the bottom? How many are in 6th grade? 42. And of those 6th graders, how many take French? 19. Good. Letter D. How would we set it up? What did you say on the bottom?
37. Oh, wait,
82?
Yeah.
Because that's how many take French. How many of those French takers are 7th graders? 25. Good. All right. Okay, I'm going to give you 2 minutes. I want you guys to do number 6. Okay, I've got the answers written up there, so just do a quick check to see if you guys got the same thing. Remember, part A is the one that doesn't have anything given, so you're just looking at the total number of juniors who didn't go to prom out of all the students. Now, the problem did not tell you the total, so you did have to add up all the numbers. That's where I got that 200 from that I wrote on the top of my chart there. I just added up all the numbers that were in my box. Okay. The rest of them, though, B and C, those are just like what we were doing. The given part, the second half in the parentheses, is what goes on the bottom. And then the top is like the specific area that they're talking about in that total. Okay. All right. I'm going to try to go through this last piece here relatively quickly because we've only got about 10 minutes left to class. So we're going to take this a step further. They're going to still have a two-way table, but now they're going to start talking about it in terms of frequencies. Frequencies would mean like percentage. So instead of looking at a fraction, because, when we see a number like 7 out of 25, 19 over 116, yeah, those are numbers, they're a fraction, they represent the odds, but what does it really mean? Like, what's the percent? It means more if I can say you have a 12% chance of winning versus saying you have like a 19 over 26 chance of winning, okay? So these charts are just going to take what we did before, and instead of looking at it as fractions, we're going to look at it as percentages. So you can see that we still have these two-way tables. This one is talking about a situation where we have people that are flying in either first class or coach and how many bags they checked. The first one they have us have is a blank chart over here that we're going to fill in with our frequencies. So first thing is I need to know how many total people were surveyed here. So to find my total, I need to add up all of those numbers. So 16 plus 52 plus 12 plus 60 plus 2 plus 18. 160. So there's a total of 160 people here. Okay? To find your frequencies, you take the numbers that they give you in the table and you divide them all by 160. You're going to get decimals. That's supposed to happen because we're talking about percentages now. So if I take 16 divided by 160, you should get 0.1. That's going to go in that coordinating box. I'm going to keep doing this with all the other ones. I'm going to take 52 and divide by 160. 12 divided by 160. 60 divided by 160, and so on, so that I fill in all of those boxes. Okay? Now you guys can do that. I've already done it, so I'm going to fill in my chart. But if you just maybe want to check a couple to make sure that you're typing it in correctly and you're getting the same answers as me, you can. Now, if the number on the top is getting significantly smaller, then your decimal is going to be smaller as well because you're still dividing them all by that 160. Now, the last thing that I need to add on is they do have columns for totals. So just like before, we're going to add our rows and we're going to add our columns together. So for example, for that 2 bags across the top, you would take 0.1 plus 0.325, and that would become 0.425. And then you would add the next row, which comes out to be 0.45. Then the next one, 0.125. Then I'm going to go to my columns. So I'm going to add up the 3 numbers in my first class column and in my coach class column. Okay, now this last box, this last total, should match. If I add up those 3 numbers, the 0.42, the 0.425, 0.45, 0.125, those should get you a number. And if I add the numbers in my row on the very bottom, it should get you a number too, but it should be the same number. What does it come out to be? Well, individually, I wouldn't add them together. So if you went down, you should have gotten 1. And if you go across, you should also get 1. Because if you think about this, guys, if I added up all these frequencies, it should equal 100%. Because 100% of the responses are represented in this table right now. Okay? So now what they're going to do is ask you questions like we saw before. But instead of answering it necessarily in like a fraction, like 12 over 160. We're going to use the percentages. So this first one says the probability that a coach class passenger that did not check any bags. There's no given, okay? So again, we're going to come up over here and we're going to see where's that at in my table. So in the coach class, what's the decimal that we have for someone who checked 0 bags?
0.1125.
Yeah, right here, because that's in coach, 0 bags. So 0.1125. If I want to make that a percentage, though, what do I need to do? Times by 100. Move your decimal places 2 to the right. So it's 11.25%. Okay. Letter B says a first class passenger, so we're in this column, that checked at least 1 bag. So at least means 1 bag or more. So I need to add a couple of numbers here. What 2 numbers from this column that I circled do you need to add together?
2 bags in 1 bag.
Yeah, 2 bags in 1 bag. So 0.1 plus 0.075, which would be 0.175, which again as a percentage would be 17.5%. Now these last 2 are the ones where it says given. So we will have to set up a fraction, but we're using percentages this time, or decimals. We're not using whole numbers. So C says coach class given they checked 1 bag. So you start where the total of 1 bag, which is this number over here in the green, the 0.45, that goes on the bottom. And out of this row, how many were in coach? 0.375. So that's going to go on the top. Okay, so you're going to divide those, which should get you 0.83, and the 3 repeats. It should be 0.83333333 forever. And then if I change that to a percentage, it would be 83.3 repeating percent. Okay, last one, guys. Checked 2 bags given that they were in first class. So how many total, like what's my total decimal for first class? First class total. Yep. You gotta say it louder so I can hear you. Checked 2 bags. So in this column, how many checked 2 bags? 0.1. So if you guys take 0.1 divided by 0.1875, that should be 0.53 repeating, which would be 53.3 repeating percent. Okay, that's it for notes. We made it.